Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 6th lesson on a given Form 4 mathematics topic called integration. So we are looking at our 9th example, which is a past cases equation tested in 2016, paper 2, question number 22. The same question was also repeated in 2007, paper 2, question number 20. It reads that the gradient function of a curve is given by the expression 2x plus 1. If the curve passes through the point -4, 6, part A, find Roman 1, the equation of the curve. So we're going to start by highlighting the key information that we are given in the question. So we are told that the gradient function of a curve is given by 2x plus 1. So of course the gradient function, that is dy dx, that is the derivative, which is given as 2x, then of course plus 1. Then you are told that if the curve passes through the point -4, 6, find Roman 1, the equation of this particular curve. Of course, the equation is y is equals to something. Therefore, to get the y is equals to something, the first step is to multiply through by dx so that we retain the term having a y on one side. So that means that we are having dy being equal to, this is 2x, then of course plus 1, then multiplied by dx. Therefore, to get the value of y, we're going to integrate both sides of the equation. Remember, we said that any multiplication by dt or by dx, that is one is telling you to integrate. But any division by dt or by dx, that one is telling you to differentiate. Therefore, we're going to integrate this particular equation. Therefore, the integral of dy, of course, will be y, which is equals to, if we integrate the first term, of course, this one is power 1. So this will be 2 x to the power of 1. To integrate, you add 1 to the power, then divide by the new power. Then plus 1. Of course, this one means it was x power 0 because we are integrating with respect to x. So this is 1x to the power of 0. To integrate, we add 1 to the power, then divide by the new power, which is 0 plus 1. Then of course we are going to add the constant of integration, since this is an indefinite integral. Therefore y will be equal to, this will be 2x to the power of 1 plus 1 will get 2, divided by 1 plus 1 will still give us 2, then plus 1x to the power of 0 plus 1 will get 1, divided by 0 plus 1 we get 1 plus the constant of integration. So clearly y will be equal to, 2 and 2 will cancel out, so we're gonna have x squared, then of course plus 1 and 1 will cancel out, so this will be x power 1, which is basically x, then plus c, which is our constant of integration. Therefore, to get the equation of the curve at the point -4, 6, we're going to substitute in our equation. So we'll say at the point -4, 6, clearly the value of x will be -4, then the value of y will be 6. So on substituting, we are going to have y is 6. So we're going to have 6 being equal to, the x is -4, but it is x squared. So we're going to have -4 squared, then plus the x is still -4, then plus the constant c of integration. Therefore, it means that when we simplify, this is what we're going to have. So this will be 6 is equals to -4 squared, that will give us positive 16. Then positive times -4 will get -4, then of course plus c. Therefore 6 will be equal to 16 minus 4 will get positive 12 plus c. I'll take 12 to the other side so that I'm having 6 minus 12 being equal to c. So clearly the value of c will be -6. But remember, our equation was y is equals to x squared, then of course plus x, then plus c. Therefore, it means that the equation of this particular curve will be y is equals to x squared, then of course plus x, then the value of c, we've gotten it as -6. So this will be -6. Therefore, this is the equation of the curve. Then we look at Roman 2, that is a Roman 2 of the question. In Roman 2, they want us to find the values of x at which the curve cuts the x-axis. Remember, the point where the curve cuts the x-axis, that is what we call the x-intercept. Therefore, we say that at the x-intercept, we know that the value of y must always be equal to 0. Therefore, it means that this equation will become 0 is equals to x squared, then of course plus x, then minus 6. So clearly this can be rewritten as x squared, then of course plus x minus 6 is equals to 0, which clearly is a quadratic in the form ax squared, then of course plus bx, then of course plus c is equals to 0. So clearly the value of a will be 1, that is the coefficient of x squared. The value of b, the coefficient here is also 1, then the value of c clearly will be negative 6. Therefore, we can solve our quadratic to find that is the values of x at the x-intercept. So clearly we'll get the product, which is usually the value of AC, which will be equal to, the a is 1, then the c is negative 6. So 1 by negative 6 will get negative 6. Then the sum is usually the value of b, which will be equal to, of course, our b here is positive 1. So this is positive 1. So on factorization, that is by 3, this will be 2. Then of course by 2, this will be 1. So my numbers will be 3 and 2. So I'm going to have 3 and of course 2. So I need the product to be negative. So I'll put my negative here. So that 3 times negative 2, I'll get negative 6. Then the sum will be 3 plus negative 2, I'll get a positive 1. So it means that my equation, which was x squared, then of course plus 1x, then minus 6 is equals to 0, will become x squared, then plus, I'm going to have 3, then of course minus 2, then of course x, then minus 6 is equals to 0. So clearly this will be x squared. 3 times x, I'll get positive 3x, then of course minus 2x, then minus 6 is equals to 0. I'm going to factor out the common term between the first two terms, which will be x. So I'm going to have x into, this will be x, then of course plus 3, then minus 2 into x plus 3, which is equals to 0. So I'll pick this one and this. So I'm going to have x minus 2. Then the second bracket, I'm going to have x, then of course plus 3, which is equals to 0. So this one means either, this implies that either x minus 2 is equals to 0, which clearly will give me x being equal to positive 2. Then the second possible value of x will be given by, so we'll say or x plus 3, that is the second bracket here, can also be equal to 0. So x will be equal to negative 3. Therefore, the values of x at which the curve cuts the x-axis will be x is equals to 2, and the other value is x is equals to negative 3. Then we check part B of the question, whereby you are told to determine the area enclosed by the curve, that is, and the x-axis. So of course the x-axis, it will be, the curve is going to cut it at the x-intercept, of which you have gotten x-intercepts to be x is equals to negative 3 and positive 2. So we have x is negative 3 and x is equals to positive 2. Then the curve was y is equals to, we already have the equation of the curve. It was y is equals to x squared plus x, then minus 6. So this is x squared plus x, then of course minus 6. So the first thing, we need to check the area. We see whether it is lying above the x-axis or below the x-axis, so that we know the area whereby we need to negate the negative sign. So the values that we are having are, the smallest value of x is negative 3. So we'll have negative 3, then negative 2, then negative 1, then 0, then 1. The largest value of x, of course, is a positive 2. The equation was y is equals to x squared, then of course plus x, then minus 6. So if I substitute when x is negative 3, this is what I'm going to have. So this will be negative 3 squared, then of course plus negative 3, then minus 6. So this will be negative 3 squared is 9, then minus 3, then minus 6. So this will be 9 minus 3, I'm going to get 6. So this will be 6 minus 6, which will give me 0. So here I'm having 0. I substitute negative 2, so y will be equal to, I'm going to have negative 2 squared, then of course plus negative 2, then minus 6. So negative 2 squared will give me positive 4 minus 2, then minus 6. So this will be positive 2 minus 6, which will give me negative 4. So this is negative 4. Then I'm going to move to the next value when y is negative 1. So y will be equal to, I'll have negative 1 squared, then of course plus negative 1, then minus 6. So this will be positive 1 minus 1 minus 6. Of course, this will be 0 minus 6, which will give me minus 6. Then I substitute when x is 0. So y will be equal to 0 squared, then of course plus 0 minus 6, which will give me minus 6. So this is minus 6. Then when x is 1, y will be equal to, I'll have 1 squared plus 1, then minus 6, which will be 1 plus 1 minus 6, which is 2 minus 6, which will give me negative 4. So this is negative 4. Then I substitute when x is 2. So y will be equal to 2 squared, then of course plus 2, then minus 6. So this will be equal to 2 squared is 4, then plus 2, then minus 6. Of course, this will give me 6 minus 6, which will give me 0. So clearly from my values, I can see that my values of y, most of them are actually negative. So this one is suggesting that the area is going to lie below the x-axis. Therefore, if I try sketching the curve, this is what I'm gonna have. Most of the values are negative. Therefore, I don't need the positive values on the y-axis. So this is y, then this is our x-axis. So on the x, I'm having up to negative 3. So I'll let this to be negative 1, negative 2, then negative 3. Then this is positive 1. I only have up to a maximum of positive 2. On the y-axis, I'll use a scale of 2. So this is negative 2, then negative 4, then negative 6. So if I plot these particular points, negative 3, 0, of course, will be here. This is negative 3, 0. Negative 2, negative 4. Negative 2 is here. Negative 4 is somewhere here. Then negative 1, negative 6. Negative 1, negative 6 will be here. Then 0, negative 6. This will still be here. Then 1, negative 4. This will be somewhere here. Then 2, 0, of course, will be here. So it means that my curve, clearly my curve will be roughly this way. So this will be my curve. So the key thing to notice that the curve is below the x-axis. Therefore, we expect a negative area. We expect a negative area. So remember that no part of the graph is cutting on the positive side. Therefore, we'll just integrate from negative 3 up to positive 2. Therefore, we say that the area under the curve, the area under this particular curve will be given by the integral from the limit of negative 3 up to positive 2. Then we integrate the equation of the curve, which was x squared, then of course plus x, then minus 6. Then we are integrating with respect to x. So on integration, this will give us the following. We are going to have box brackets. So if we integrate the first term, which is x squared, this will be x squared. We add 1 to the power, then divide by the new power, which is 2 plus 1. We integrate the second term, which is power 1. It will be x to the power of 1. We add 1 to the power, divide by the new power. Then minus 6. This one means it was x power 0. So this is 6x power 0. We add 1 to the power, divide by the new power, 0 plus 1. But because we have the limits of integration, we are not going to add the value of c because it will cancel out anyway. So this means that we are having the following. This will be x to the power of 3 divided by 2 plus 1 will be 3. Then of course plus x to the power of 2 divided by 2. Then minus 6x to the power of 1, which is basically x. So of course the limits are from negative 3 up to positive 2. So we start by substituting the first limit that we are having, which is positive 2, or the upper limit. So this will be 2 to the power of 3 over 3. Then of course plus the limit is 2 squared over 2. Then minus 6 into the limit is 2. So that is the first bracket. Then minus the second bracket, will substitute the second limit that we are having, which is negative 3 So this will be negative 3 cubed, then of course divided by 3, then plus negative 3 squared divided by 2, then minus 6 into negative 3. So this is going to simplify into the following. So of course 2 power 3, that is positive 8 divided by 3, then plus 2 squared is 4, 4 over 2, that will be 2, then minus 6 by 2, of course that will give us 12, then minus the second bracket will give us negative 3 cubed, this will be negative 27 over 3, then of course plus 3 squared, that is 9 over 2, then minus negative 6 times negative 3, this will give us positive 18. We're going to get positive 18. So on simplification, this is what we are going to get. That is when we simplify, this is what we are going to have. So you gotta get the following. So this will be equal to, you take 8 over 3, then of course plus 2 minus 12. Your calculator is going to give you negative 22 over 3, negative 22 over 3. Then minus, you take negative 27 over 3 plus 9 over 2 plus 18. Your calculator is going to give you 27 over 2, 27 over 2. So this one means that we are having negative 22 over 3, then of course minus 27 over 2. So you feed this on the calculator, negative 22 over 3 minus 27 over 3. Your calculator will give you negative 20 whole number, 5 over 6, 5 over 6. So you can see that you are getting a negative area. The reason is because clearly from the sketch it was below the x-axis. Therefore, we'll conclude and say the area under the curve will be equal to positive 20 whole number, 5 over 6 square units, but the area is below the x-axis, below the x-axis, below the x-axis. So the word below the x-axis is the one standing in for the negative. So that was the expected solution. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.